Probably some of the students are preparing for IPE board, it seems. Rotating about an axis away from it. You can see here AC is the conducting rod, whereas OA is an insulator. Right. It is a rotating. Fine. Now, my point is how I will do this question, I will explain. I imagine that suppose if this is the conductor, IC ion, inward, it is in, actually it is in anti-clockwise sense. If it is inwards, anti-clockwise, IA, IP. So therefore, in this case, inward, anti-clockwise, inner end is positive, outer end is negative. If I take it as VO minus VC, for example, I would have written that, of B L square omega. So this is root 2L square omega. Suppose if OA is another rod, you would have written this as BL square omega. So what you can do is equation 1 minus equation 2. You'll get VA minus VC as BL square omega by 2. That's what they're asking. Simple. That's what they're asking. That's it. Not more than this. Okay? Just not more than this. A simple question. But any student having doubt, please ask me right now. Geetika, any doubt?
No, sir.
Alvita, do you have any doubt?
No, sir.
Nidhi,
No, sir.
right. Next. This is also a very famous question. Very famous question. Try this. So because I was told that some students are writing exam tomorrow, I'll take up class till 12:30 and I'll stop. Maximum theory from my side is done. Related to this week's syllabus. ఎవరిని మీరు చూడటం అలా చూడకూడదు. వాళ్ళ ఫస్ట్ క్వశ్చన్ మన ఫస్ట్ క్వశ్చన్ వేరు. టీచర్తో చేయించండి. మెయిన్స్ లో అలా ఉండదు. క్వశ్చన్ వేరు. సెకండ్ వేరు. ఇంకా ఫంక్షన్లో మీరు ఏం చేయాలంటే సొల్యూషన్స్ పక్కన పెట్టుకుని సొల్యూషన్స్ తో చెక్ చేయాలి. చరిత్రలో వస్తుంది. నేను వస్తున్నా లేదు, ఒకసారి చూస్తాను. గీతాలో సమస్య లేదు. ఏ సబ్జెక్ట్ చూడండి. ఒకసారి Sliding rod connected to a spring. In the arrangement shown in the figure, a capacitance connects the ends of two long, smooth, parallel conducting rails. And you have released it from some distance x naught, the entire space. What do you want in this question? Find the time taken by the connector to reach where the spring is unstretched. Actually, what is happening? Let us study. Suppose this is your rod. And this is moving in this direction. Velocity. Let this be A, let this be P. Or PQ, whatever it is, no issues. This is an inward current, inward magnetic field. What we need to use is right hand. Inward, thumb leftwards, central finger downwards. Means this will be minus and this will be plus. And this is charging the capacitor, by the way. And this is the current at that instant. I can be given as dq by dt. And in this is the current. Right. Now here you can see spring exerts some force kx. You have some velocity v. Right. So Q by C is BVL. That is one equation. Net, what are the forces? Now, inward magnetic field, rightwards is magnetic force. So, what is the force in this case? F net is Kx minus Fb. Kx minus BIL. Hold on, no issues. F net is M dV by dt or whatever it is. Right. That's what the situation you have. Let us try to understand preferably what is happening over here. Now let us try to differentiate equation with respect to time. That is also there. Differentiating with respect to time. Let this be equation 2. Now with these equations, I can make it as m dv by dt is equal to kx minus b. I means this part. B square L square C. I means B square BLC. B square L square C dV by dt. Therefore, M plus B square L square C. I am taking X as an instantaneous distance of separation from the equilibrium position. dV by dt is kx. So acceleration is k by m plus b square L square C times x. Remember, you have displaced rightwards, acceleration is leftwards. They are opposite in sense. So therefore, obviously, what is going to happen in this? The entire term will act as omega term. So therefore, omega is k by m plus b square L square C. That is the deal. Any doubts? Boys and girls, do you have any doubt?
No,
Sure,
no, sir.
sure. Any doubt, please ask me without any hesitation. But this is not your answer, no? What they are asking is 1/4 of the time period. Yeah, they are asking 1/4 of the time period. So answer is T by 4. This is nothing but 2 pi by T. They're asking 1/4 of the time period. Pi by 2 times reciprocal of this. Any doubt, please ask me now. Any student.
Sir, how T by 4, sir?
What is that they're asking? Find the time taken by. No, is it executing SHM or not, first of all?
Yes, sir, it is.
Now you ask find the time taken by the connector to reach the original position from here. From here to here, what time it will take? 1/4 of the time period.
Yes, yes, sir.
Right. Go ahead. Next. Go for the next one. Try this. Two parallel wires and a square loop. Two fixed long parallel wire carries a current I in the opposite directions as shown. You can see that they have a. First of all, what is the flux due to this? Let us take one. One represents this. What is the flux due to one? That we will first assess. Flux due to one is given as, here you will take a small elemental portion. You will define that this is at a distance x, this is a dx. Flux in this case is, anyone in the class, can you tell me what is the direction of the flux due to that current carrying conductor? Inwards or
Inward, sir.
correct? Correct. So therefore, mu naught by 2 pi I by x dx into, it is a square into d. And the limits are d2, limits d to 2d, because with respect to this conductor, one end is at d, the other end is at 2d. So you will get this as mu naught d into I. Hold on. First, let me complete this part by 2 pi times log E2. Similarly, flux due to the other, this one is inward flux. Flux due to other is plus mu naught by 2 pi times, it is from 2d to 3d. Everything is the same again. So you will get the answer as mu naught d by 2 pi I natural logarithm of 3 by 2. So what is the net flux? Mu naught d by 2 pi I into log E 1.5 minus log E2. It is like log m minus log n, log m by n. Allowed? No one is answering. Allowed or not?
Yes, sir. Yes, sir.
In that case, you will get the net flux as mu naught di by 2 pi times, maybe minus will come, log E 2 by 3 by 2, 4 by 3. And they got 2 by 3 by 2, 4 by 3. Keep this aside. That is not your question. What is that? They calculate the induced EMF. EMF induced is minus d5 by dt. This will become plus mu naught d natural logarithm of 4 by 3 by 2 pi times di by dt alpha. अरे प्लस आया, इसका मतलब the EMF induced is in anti-clockwise sense. What is the direction of force on the loop due to the parallel wires? What is the direction of force? Either direction only is what they are asking. Fortunately, we can manage. Okay. Can you please tell me what is the direction? What is the direction? Simple. In this case, the current is like this. Induced current, I naught. By a air repulsion, this is repulsion, this is attraction, but repulsion dominates. So obviously, due to first wire itself, what will happen? Repulsive. Net is repulsive. Second wire, very far. See, please try to understand the influence of this on that is less when compared to the influence of the first one on the loop. So what happens to the first loop is what we need to consider. Repulsion. So this case, net is repulsion. But still, if any student having doubt, please ask me. Any student having doubt, please ask me. Don't hesitate. Are we clear? Boys and girls,
Yes, sir.
right? Nidhi, you are not answering.
Sir, I'm there, sir.
నువ్వు ఉన్నావమ్మా, నీకు అర్థమవుతుందా?
Yes, sir.
రైట్. గీతిక ఫాలో అవుతున్నావా?
Yes, sir.
సహస్రా,
Yes, sir.
అవును, ఈ అమ్మాయి రావడం లేదు 2 రోజుల నుంచి. లాస్ట్ క్లాస్ కి రాలేదు. పల్విత, మన అమ్మాయి పేరేంటి? మన స్కూల్ అమ్మాయి. మీరైనా చెప్పాలి కదరా. మన క్లాసులకు వస్తుంది కదా అమ్మాయి, 2 క్లాసెస్ నుంచి రావటంలా. రైట్. నెక్స్ట్ క్వశ్చన్. రైట్. Example 14. Go ahead. For this, you need to recall if you have 2 dipoles like this, they will have a repulsive force given by mu naught by 4 pi times 6 m1 m2 by d cube, because I have derived the same thing with electric dipoles. If you have dipoles like this, the force of repulsion is 1 by 4 pi epsilon naught 6 p1 p2 by d power 4, d power 4. I have used this relation here, and you might require this relation over here. Find the magnetic force that opposes. A small bar magnet of dipole moment M is moving with, right. Now, at an instant when it is X, the flux linked with coil. Mu naught by 4 pi 2 capital M by X cube, because the coil is on the axial line. So flux linked is B into pi a square. EMF induced is minus d phi by dt. So this is nothing but mu naught by 2 pi m a square into pi 1 by x cube 2 by x square 3 by x square dx by dt. That instant dx by dt is velocity. So the magnitude of induced EMF can be given as pi cancel 3 mu naught capital M by 2x square V. Current induced is EMF by resistance. EMF by resistance. 3 mu naught capital M by 2x square RV. That is the current induced. Now it acts as a different magnetic moment. No, I think you said a loop. loop means only one current, I into pi a square. So this will become pi a square of this. So 3 mu naught m v pi a square by 2x square r. అరే ఇంత చేస్తే you derived m2. Finally, what is the force? Mu naught by 4 pi 6 by x power 4 m1. Here it is m1, 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 m2. Just substitute, you will get the answer. You will nearly get the answer as I don't have space. You will really get answer as rear 3 by 2. కింద 2 పైన 3 9 by 4 వస్తుంది. పై ఎగిరిపోతుంది. You won't have pi term. You have mu naught square term, m1 square term, a square term, v term divided by ఇక్కడ x power 4 x power 2 కాబట్టి x power 6. మీకు తెలుసా ఒకసారి ఐఐటిలో ఇదే క్వశ్చన్ అడిగారు, ఎట్లాంటి క్వశ్చన్ అడిగారు. నేను చూడండి ఈ క్వశ్చన్ ప్రతి సంవత్సరం చెప్తాను, మీరు నోటీస్ చేస్తున్నట్లయితే ఇలా రౌండ్ ఆఫ్ అయి ఉంది, ఎప్పటి నుంచో చెప్తున్నా. ఇది సేమ్ క్వశ్చన్ ఐఐటిలో అడిగారు. ఇట్లా ఇది తెలిసిన వాడు అది చేస్తాడు. ఎనీ డౌట్ ఇన్ దిస్ క్వశ్చన్? బై
M2 ఎలా రాసుకున్నారో ఒకసారి చెప్తారా సార్?
M2 రా, if you see, if the coil is carrying some current, say I for example, the magnetic moment is equal to current into area. అంతేగా?
ఓకే ఓకే సార్.
ఎనీ డౌట్ స్టిల్ ఆస్క్ మీ, ఎందుకంటే
sir.
నెక్స్ట్ క్వశ్చన్ చేయమంటా మిమ్మల్ని ఇప్పుడు. If you are through with this, I expect you to do the next question. Are we clear?
Yes.
Any student online? Right. Why don't you try this? నేను ఈ 2 క్వశ్చన్స్ చెప్పి తీసేస్తాను ఇంకా. Keep working. I hope you are doing. I think this one is the question given in 2021. Right, we'll go with this. When the dipole, what is the difference between these two questions? When the dipole is placed at a distance r from the center of the loop, shown, the current induced in the loop will be proportional to what is a dipole moment. Now here we have already this question. Why you are doing too much of time? You have already this question, m by x square, magnetic moment by x square. So any such option you have, magnetic moment by x square. Yes, you have the option. The work done in bringing the dipole from infinite to distance r from, it is like potential energy. It is like potential energy. It is almost, see, if it is force, you have this expression. If it is potential energy, you will have P1, P2 by d to the power of 3 actually. M1, M2 by d to the power of 3. Force potential energy. M1, M2 by d cube. So actually, what is that you are supposed to have? Potential energy is proportional to M1, M2 by x cube. Right. But till now, what we have done, M2 we have already. M2 contain M1 by x square term. M1 by x cube into M2 itself contains M1 by x square term. This is M1 square by x power 5. So let us see M1 square by x power 5. Right. అరే ఎంతమంది చేశారు ఇది చెప్పాలి రా ఒకసారి ఎంతమంది చేశారు భగవత్ చేసావా ఇది
ఎస్ సార్ అయిపోయింది సార్.
ఆ చేసిన వాళ్ళు చేయగలరా చేయలేరా చెప్పండి ఒకసారి. ఇప్పుడు నేను క్లాసులో ఇది చెప్పాను, ప్రతి సంవత్సరం చెప్తాను, ఇది ఎప్పటి నుంచో ఉంది పుస్తకం. ఇప్పుడు ఇది ఆ పిల్లలకు వచ్చింది, వాళ్ళు చేయగలిగారు. ఎవరు చేయలేరు? ఇప్పుడు కూడా మనం ఏదో సినిమా చూసినట్టు చూసేసాం అనుకోండి, చేయలేరు. నెక్స్ట్ టైం అయిపోయింది నాకు కొంచెం. ఐ స్టాప్ ఓవర్ హియర్ ఫర్ టుడే. మధ్యాహ్నం ఏదైనా అవకాశం ఉంటే నేను మళ్ళీ మెసేజ్ పెడతాను మీకు. ఎనీ టైం బిట్వీన్ 3 to 4 కుదిరితే నేను చెప్తాను మళ్ళీ. రైట్ రైట్ ఓకే, దట్స్ ఆల్. మీకు నెక్స్ట్ క్లాసు రమేష్ సార్ చెప్తారు.